Hello learners, welcome to Naga Aima courses. It is Venkat Narendra Nalajalla standing before you. In the last video, we covered the random variable concept, and in today's class 4, we start our topic with functions. What are conditions for a function to be a random variable? Starting here, is my voice is audible for you? Conditions for a function to be a random variable. Okay. First condition. Say for example, it should not be multi-valued function. What does it mean? Already we covered in the last video that where every element in the sample space will have unique element in its range. That means it should not be multi-valued, where it maintains one-to-one correspond between the domain and the range. That is the interpretation here. Okay. Next point. Say for example, here we are taking some probability of x less than or equal to x. What does it mean? The probability of all the possible outcomes for which it is bounded by some real number x. It never exceeds the value of x. It should be bounded. Similarly, the probability of x is equal to minus infinity is equal to probability of x is equal to plus infinity is always equal to 0. What does it mean? The probability defined at extremities, either minus infinity or plus infinity, is always equal to 0. Okay, these are the conditions for a function to be a random variable. Okay, next we are moving on to the actual topic, that is next topic, that is distribution function. Distribution function. What is distribution function? Distribution function is equal to the probability of capital X less than or equal to X. This is equal to distribution function. How it is denoted here? It is denoted by capital Fx of X. It is denoted by capital Fx of X is equal to probability of capital X less than or equal to small x. It is by definition, distribution function is equal to probability of all the range of possible outcomes for which the random variable is less than or equal to x, where x is the upper bound. Okay. Distribution function is also called as it is also called as cumulative distribution function. It is abbreviated as CDF. Distribution function is also known as cumulative distribution function. Okay. Next, here what is this x here subscript indicates random variable, and what is this small x here argument, that is a real number. Okay, here the real number might vary between minus infinity and plus infinity, something like this. So for example, x is vary between infinity and minus infinity. The range of this real number. It varies between minus infinity and plus infinity. Now we shall move on to properties. Properties of distribution function. What is the first property? First property states that fx of minus infinity is equal to 0. Okay. Second property states that fx of infinity is equal to 1. Third property states that fx of x is bounded between 0 and 1, just like probability. Distribution function is bounded between 0 and 1. And fourth property, fx of x1 is less than or equal to fx of x2 if x1 is less than x2. Fourth property. Fifth property, probability of an event, probability of a given random variable where it exceeds some number x1 but not exceeding another number x2. Probability of something x1 less than x less than or equal to x2. What does it mean here? The random variable is more than x1 but not exceeding x2 is equal to fx of x2 minus fx of x1. Fifth property. Okay, now we are moving on to the sixth property. Fx of x plus is equal to fx of x. What does it mean? Sixth property states that the function is continuous from right. Okay, totally we have 6 properties here. Okay, let us go in detail. The first property states that fx of minus infinity is equal to 0, fx of infinity is equal to 1. Third property, distribution function is bounded between 0 and 1. Next one, fourth property. What is fourth property indicates here? Fourth property, property 4 indicates distribution function fx of x is a non-decreasing function of x. It is a non-decreasing function of x. What does it mean here? The value is, the distribution function is an increasing function. Okay, fx of x1 is less than or equal to fx of x2. Okay, what is the fifth property? Fifth property states here that probability of an event where greater than the number x1 and less than or equal to another number x2 is equal to algebraic difference of the distribution function defined at x2 and x1. That is why fx of x2 minus fx of x1. What is this sixth property? Function is continuous from right. Okay, now it is clear. Let next topic. Let gx of x be an arbitrary function. Arbitrary function is said to be valid in nature if it satisfies properties 1, 2, 4 and 6. Okay, observe here how many properties is 6 properties. Among these, if it satisfies properties 1, 2, 4 and 6, where we put some tick marks. If all these properties are satisfied, then you can say an arbitrary function gx of x is a valid distribution function. Okay, is it clear? Say for example, x random variable x is discrete in nature. Then how the distribution function is represented here? If x is a discrete, I am using shorthand notation. RV stands for random variable. Then fx of x is equal to algebraic summation of I is equal to 1 to n probability of xi into u of x minus of xi. What does it mean here? Distribution function can be represented in terms of unit step function with how many sample points were ranging from I is equal to 1 to n. What is the corresponding amplitude, the corresponding at individual sample points, that is equal to probability of xi. Okay, now where u of x is called as unit step function defined as 1 for x greater than or equal to 0, and u of x is equal to 0 for x less than 0. What is u of x stands for here? U of x is called as unit step function. It is a unit step function. Okay. Now let us have some small simple example problem. A discrete random variable has a distribution function which is given like this here. Fx of x is equal to algebraic summation n is equal to 1 to 5 n square by 60 into u of x minus n. Okay. For this we need to determine the following. What is the first one? Say for example A. We need to estimate probability of minus infinity less than x less than equal to 4.5. If we want to get this one, which property we have to refer among these 6 properties? Just try to check. This is in the same form as property number 5. Hence, we need to go with the same substitution here. Apply this 5th property here. What do we get here? Is equal to fx of 4.5 minus fx of minus infinity. Okay. What is the value of fx of minus infinity from 1? First property 0. Now it is being reduced. Fx of 4.5 minus 0, that is resulting in the same form, fx of 4.5. What is fx of 4.5 in terms of probability? Fx of x is equal to probability of capital X less than or equal to x. Hence we get this form for the given function n is equal to 1 to 4, because less than or equal to 4.5. We have only distinct sample points. We cannot get some 4.5 like. Therefore here next continuation n square by 60 into u of x minus n. After substituting this values here, different possible values, what we get here? Take this 60 as common. 1 by 60 into n square, substitute n is equal to 1 square plus 2 square plus 3 square plus 4 square. Okay, is equal to 1 by 60 into 1 plus 4 plus 9 plus 60. Okay, 1 plus 4, 5, 5 plus 9, 14, 14 plus 16, 30. Hence it is equal to 30 by 60 is equal to 1 by 2. Okay, it is one step. So for example, we are moving on to the another step in probability of x greater than 2. Already we know in the last video already we covered where p of a bar is equal to 1 minus of p of a. We substitute the same notation here. Then what we get in 1 minus of probability of x less than equal to 2. Again it can be written as 1 minus of what is probability of x less than equal to 2 given by fx of x. Hence 1 minus of fx of 2. Hence it can be written as 1 minus of algebraic summation n is equal to 1 to 2 n squared by 60 into u of x minus n. What is it presenting in here? 1 minus of 1 minus of here we take the 60 as common. 60 1 square plus 2 square 1 square 1 plus 4 something. Yes or no? Here is equal to 1 minus of 1 plus 4 means 5 by 60. 5 by 60 means it is cancelled for 12 times. What is left over is equal to, in simplification you get 11 by 12. Okay. Next step we want to evaluate C, probability of something 1 less than x less than or equal to 3. So for example 3. Again we need to apply the fifth property. Hence what is we are getting, what is the next step here? Fx of 3 minus fx of 1. Fx of 3 minus fx of 1. In fx of 3 we have range of values 1, 2, 3. In fx of 1 only we have 1. Then after subtracting this 1 from 1 to 3, what are the resulting values ranging from algebraic summation n is equal to 2 to 3 n squared by 60 u of x minus n. After substituting this value, what we will get in 1 by 60, 2 square plus 3 square. No, 2 square means 4. 4 plus 9, 13. Hence it is 13 by 60. With this here covered till now, what are the conditions for a function to be a random variable, and the definition of distribution function the fx of x equal to probability of capital X less than equal to x, and the 6 properties. Given arbitrary function gx of x is said to be valid in nature if it satisfies properties 1, 2, 4 and 6. If it is if it is a discrete random variable, then fx of x is equal to probability of algebraic summation I is equal to 1 to n probability of x into u of x minus xc. Okay, yeah, and the unit step function is equal to, unit step function is very very important application point of view. The standard function u of x is equal to 1 for x greater than equal to 0 is equal to 0 for x less than 0. Okay, next we have seen some small example problem in relation with the discrete random variable. Okay, please wait. Okay, in continuation we shall see another example problem. Example, a classroom consists of 100 students. 100 students. the number of girls and boys are 60 and 40. Assuming the occurrence of probabilities of girls and boys are at x is equal to 1 and x is equal to 2. This is the given data. With this given data, we need to obtain the distribution function and density function. Okay. Our next topic is density function. For the time being, we shall get the density function, the derived form of distribution function. We shall see in detail in the next video. Okay. Determine and sketch the distribution function and density function. Okay. So for example, total strength is 100. Then what is the probability of girls? Probability of girls is equal to 60 by 100 is equal to 0.6. What is the probability of boys? Is equal to 40 by 100 is equal to 0.4. Okay. We have two different possibilities, and also we have two different point of occurrence of the probabilities. Hence, one is at x is equal to 1, the other one is at x is equal to 2 as given in the data. First, let us plot this sketch here. Plot the sketch here, where it is. It is origin. It is distribution function f(x) of x. It is x. How the density function